share VirtualBox. So I've got VirtualBox running right here. And as you can see, here's the two test virtual machines that we have put together last session. And so I'm actually going to remove these, which will actually be a useful demonstration for you guys. So if I remember correctly, this was actually the one that I cloned. So I'm going to go ahead and remove these because I don't need them. Delete all the files, so it gives you the option to, one thing you want to notice is that when you are removing a lot of these, this is something that will get you in the end, especially if you run through a lot of different cycles. So I kind of want to show it to you all is if you're in the habit of creating a lot of virtual machines and then deleting them and then installing new ones and going back and forth throughout the class to try and get some of the test material together and trying to get the examples working, you're going to run into a situation where if you aren't making sure to clean up the drive images and everything with this, with the, give me a second, with the delete all files, then that will, that will fill up your hard drive. So, you know, I put those together as a really quick example. Last time that we were working on everything, this time I've actually got a Windows VM, which is this one, which is basically the modern IE, so modern.ie. So it's basically the you know, the image that's available off of here, virtual machines, Windows 7. So it's specifically this particular one up. It's basically you know, the Windows 7 image right here, the IE9 Windows 7 image. So, you know, that's basically what I will tell you is that in class, we'll probably use some of these Windows 7 images, maybe the Windows 8.1 image, and then also the XP image that is not displayed here for some reason, but I do have a copy of. Because we are doing malware analysis, we'll be using a lot of malware that has been kind of readily available for a long period of time. So just to kind of make it so you don't take the entire class period to have to deconstruct one relatively novel tool. So that said, I'll bring up the Windows 7 VM that I have here, and then I have the Kali VM right here. So I'm going to share both of these. This Kali VM is mainly going to have, it's basically going to be more or less like this. You'll boot into it with the username and password information that was available in the last class, and basically you can use a bunch of the tools that are here. So what it comes with primarily is good ones are like Metasploit framework. Again, these are for a lot of the vulnerability and pen testing and things like that, and Armitage. We'll be using those for some of the examples that involve creation of malware and creation of attacks in the class. So when you pull Metasploit off of, or Kali off of the website to download it from off of Offensive Security's website, typically it requires a little bit of setup for Metasploit. So I've already gone through some of that setup to make sure the database is searchable and everything. So for instance, you can like search for, I think like this, and it relatively quickly generates a bunch of like, you know, a bunch of test exploits for you to go and look through. So that stuff is what we'll primarily be building our, building some of our attacks with, although we may not be limited to just the exploits that come on here. So the other thing that I will tell you is that throughout the course, I may push up newer versions of the Kali image as I add some more tools that are going to be useful for particular assignments I'm going to give. Excuse me. All right, so I'm going to get out of that. The other thing that I found to be useful, and I kind of talked about it Thursday, I'll show you again today, is that I've got Kali up and running right now. So a lot of times what I like to do is rather than actually powering off the machine like I would power off my laptop, I'll actually save the machine state, which is this first bullet up here. So this allows me to basically save the system state to disk. And then as you can see, it says it's saved right here. Then that allows me to use the snapshot features, which is present, and that's what this little box right here is showing me, is the basically the system state snapshots that I can take. So I'm going to save a snapshot of this one. And the reason I would do this is maybe because I can say like base image. So maybe it's, just saving a copy of whatever the Kali Linux image was then, because I want to go and install some software or something like that. The other thing I might do is I might want to clone this so that I can basically have two images. So not only will I be able to have not only will I be able to have a a saved VM, or basically a different VM, I will also be able to run two versions of Kali at the same time if I want to. For instance, if the attack that I'm putting together or the malware that I'm trying to work with happens to require, happens to be useful to have two systems for that example. A great demonstration of this will be that network analysis, so traffic analysis and traffic capture. So trying to capture the traffic that's being sent between an attacker's machine and a target host, or the target host and the attacker's machine. Analyzing that data is a good use case for why you would have, say, maybe a second Kali clone, where I would use this top one as potentially my attack machine. I would be launching the attack from there, or I would be trying to deliver the malware from there to the Windows machine, which would be the the target, the client, the end user, whatever. And then the Kali clone that I just did would still have all of the Kali tools on it, but I might actually use it to be a monitoring machine to try and do the traffic capture or something like that. So this is where basically using the snapshot system to also generate clones is going to come in very handy. The other benefit is that when I decide I don't need that clone anymore, I can just remove it, just like I showed earlier. The nice thing is that when I said to delete all the files there, it will only delete all the files that were part of that were newly added by that clone. So all of the original files that are part of this base image here that I cloned from, those files will not be deleted. They'll stick around. So you can actually see it even created a snapshot and it saved it right here. So the other thing too with snapshots is a lot of times you can, I'll run it again. We'll just do this for demonstration, so I'm not going to do a whole bunch. Maybe pop open another program or something like that here, right? So maybe we'll just do this. So maybe I'll like load up Firefox or something, and then I'll have that up. And so what I'm going to demonstrate here is a process that I tend to do when I'm running through a system. So yeah, I'm going to go and pop it up, and it's going to bring up a whole bunch of stuff. You'll notice I don't actually have this one connected to the network right now. Yeah. I loaded on my home. Yeah. And network. Yeah. Yeah. So I manually changed the settings in this one to turn the network off, and I'll get to that in a moment. So a lot of times when I'm messing with all this stuff, my habit tends to be to turn off a lot of, basically run a disconnected network. And I'll get to the network settings in a second. So now what I've got here is I've got the current state, which matches the snapshot right here. And then I've got an intermediate snapshot, and then I've got the base image. So basically what I have here is I have files that are spread across like 4 different snapshots. And any one of these I can actually choose to go back to if I want to, or I can even pick one of these. Like if I wanted to, I could actually clone a new VM that's based on this, basically before I loaded up Metasploit and before I loaded up Firefox and all that stuff. The other thing too that I can do is if I decide, this is where when I'm trying to do something that's a complicated set of steps, and it's very likely that doing one of them wrong will end up destroying everything. What I tend to do is I will actually, take snapshots a little bit along the way and basically build a large number of these, and then finally, when I get the system to like a nice final working state or something like that, I might choose to go and delete. Now let me see how well this works. I might choose to delete some of the intermediate snapshots, and it'll let you basically compress those back together. So, I might do that. So now we're all the way back where still the current state. Remember, I just deleted all the intermediate snapshots, which means that I no longer have the ability to restore back to, say, the empty image when the system desktop was up with, without Firefox loaded. And it doesn't have the information in there of me running Metasploit that first time. But as you can see, this is still that, that top image, that most recent image that I ran where Firefox was running. So then, after I do have some snapshots like this, if I want to, and this is probably the most, so here we go, this is the image that I'm running for those of you who are on remote. If I end up deciding that, okay, I've gotten as far as I want to go with this, and now I want to, I got all of the information out of running the malware inside of the virtual machine, now I want to restore back to, the last known good, I can actually power it off and restore basically the most recent snapshot. Or what I would say is, whenever you run a VM, if you noticed that when I had 4 snapshots on there, only one of them was actually highlighted in bold. That's what it considers to be the most recent or the most active snapshot, or basically the snapshot for which this current state is derived from. So clicking this box here, which is restore the current snapshot to that, and it gives you it in text there as well, is a very quick way of allowing me to perform the refresh cycle, where I basically infect my VM, let the malware do whatever it's going to do. Then I go and inspect all the different pieces, all the different aspects of the system to see what happens, to do the little bit of the forensic analysis and everything like that, maybe extract the files, all that stuff. Once I've done all that and I want the VM to go back to the way it was, the pre-infected or the uninfected state, I would basically choose to power it off and then click this checkbox. And then it'll basically restore back to normal. or to the original state that it was. So. So that's that's set up. Ditto for the Windows VMs. This one can sometimes be really useful as well. I'll probably have some examples where I have like multiple Windows systems running at the same time that I'll demo to you. I probably won't use a whole lot of that for the assignments, mainly because I do realize that if you get over like 2 VMs running on a lot of you guys' systems, then there will probably be some performance issues and some impact to being able to deliver on the assignments. So, but basically what I would do, well, I'm not going to redo it all, but basically what I would do is I would basically click this, save the machine state, and then basically I can clone and I can make a whole bunch of more Windows 7 VMs. For the target VMs, the ones that I would like to attack, a really good reason for doing that type of thing is, so a good reason for making a large number of clones of the target virtual machine, like in this case the Windows 7 client, is if I want to, for instance, play with how the malware behaves on different versions of Internet Explorer. I can't very well install 5 versions of Internet Explorer on one virtual machine. I basically have to have 5 different virtual machines that are each configured with different versions of Internet Explorer. So for instance, I'd clone this one, and just a, just reminder, you can only clone it if, where did I put it? You can only clone it if you save the state or if you powered it down. So it won't actually let you clone a running image, but save state's nice because it's virtually running, as we established in the last class. So, all of that stuff is kind of the basic functionality that I'm going to rely on the snapshots and the cloning system for. We demonstrated the importing and exporting. Well, we demonstrated the importing of appliance. I actually did, so for this one, I'll load Kelly back up. Double click it. I can basically do the export appliance, and that allows you to pick one of these. After you pick one of the VMs to export, then it lets you create that OVA image. So for instance, if you want to, share an image with, one of your lab mates or something like that, you can do that. So I'll load up Kelly. Okay. So then the next thing that I'm going to go into talking about is going to be the networking. So the networking can be a little bit tricky sometimes, and I'll go into basically a on-screen example to try and illustrate why. With the networking, one thing you have to keep in mind, you have to remember, is that a VirtualBox itself has a piece of software that's pretending to be a network card. It's pretending to be the network hardware. And there's a bunch of different kind of like software-defined ways that it can do this. Typically, when you have Kali installed by default, or when you first import Kali, usually it's set to this, which is NAT, or Network Address Translation. That's basically the same, or I should say that's a software implementation that attempts to do the same thing as like plugging any laptop into your, your Linksys router or something like that at home, right? So the way that most of those things are set up, or even the UC network itself. So generally speaking, it's actually a really great example. If I can go here to the Wi-Fi, right? actually, you know what? I'll just do this. So a lot of you are familiar, may or may not be familiar with command .exe. Give me 1 second, and I need to share this. There we go. So IP config. So UC basically gives you, or gave me, this address right here. Let's see. There we go. Give me that address. So 10.52.248.64. However, that address is not actually accessible on the internet. So there's another machine on UC's network that actually has an internet IP address, so an address that's available on the internet. And my box, my laptop, and your laptop, and everyone else's laptop here is basically configured to send all of its traffic through that thing. And that machine is right here. So in my case, it's 10.52.240.1. That structure where you have another machine that's responsible for being that relay, that structure is implemented in software by default right here using the NAT. So what I would say, and the practice that I usually use for that, is that if I happen to want to download anything from the internet onto my VM or onto my Windows machine or something like that, or I should say on my Kali VM or on my Windows VM or something like that, I usually set the virtual machine to NAT. However, the one thing to keep in mind, and this is why it can be kind of, this can be kind of painful or just kind of convoluted, is that I set this here in the network adapter settings. A lot of times also, I need to also make the change here. So I've changed the network hardware and basically how that UC side of the network is configured. Down here, I actually need to go and let me see if I can do it here. So in Kali, it's very easy. It's very easy to access. Right here, you can actually get the wired settings. So another thing to remember is that it's going to say wired network here. That's because, again, you're faking or pretending to implement a wired network. So from, that's actually a good thing. And from the virtual machine's point of view, the virtual machine has no idea that I'm actually connected to a wireless network. That's part of the virtualization in play there. So after I've made that setting, I also, if it's not set already, I also need to make sure that inside the VM, the operating system that it's running is modified to also catch up with that change. So once I do this, I should be able to get on the internet, right? See what happens. And didn't work, not surprising. Probably because I need to also do this. So the other thing too that I'll point out to everyone here is the connect network adapter. Sometimes you need to also disconnect the network adapter, basically unplug it, and then plug it back in to try and convince the operating system. So you can see up here, there was that little network icon. It disappeared and now it came back. Sometimes you might need to do that kind of unplug, plug it back in when you change the network type while you're running, in order to make the operating system aware that basically you have you need the operating system to refresh the network settings. So as you can see, it's all working. So this is great. I can access the internet. The one thing I can't do with this is I cannot talk to any other virtual machine I have in my system. In fact, I can only talk to my host system. But of course, as we discussed during the previous week's class, just being able to talk to the host system isn't always the most ideal thing, especially when you want to go and safely handle malware and everything. For instance, like any of you who might be using a company computer or basically have to do this type of work on a company computer at work, you probably have software on there that tries to prevent you from being able to deal with malware samples and even install some forensic tools. This is where being able to actually have the VMs talk to one another tends to be beneficial. So what I'm going to do, let me actually see if this, so there is some sort of whiteboard thing in WebEx. Find it. Here it is. See if this works. So we'll experiment with this. I don't necessarily want to use the whiteboard for the sake of all the folks that are over there on the Northrop Grumman side, but basically, I basically have, I'll draw like one big box. That big blue box is going to be my laptop. So we'll just do like, laptop, right? See how that works, right? Then I'm going to this, and then basically have my Ellie VM, and then I'll grab another color, let's say green, for here. So basically, this is my Windows VM, right? Win7, and then this one here, we'll just call this Ellie. So both of these are set up to work right now. So both of these right now are set up to go directly out to the internet. Let me just try some. So how they basically do it is, let's see how this works. Nope. That doesn't work. Okay, well, whatever. I'll put the label back in there. So basically, they're set up to basically go out to the internet through my laptop like this without being able to talk to one another, right? So what I want to basically do is I want to break down both of those, set them up on a network like this, and this is where it gets into the situation where it can be beneficial to have like multiple VMs. So I'm not going to do that today. There we go. So we'll do this, right? So basically, I've got a line between the two of them, and I don't want that line to be a connection to the internet at all. So what I'm going to do in order to get that working is I will set up what's called, there's actually two types. You can either do internal network, or you can do so the difference between these two things, so these are, basically two settings that you can choose from. So I'm going to downsize, reduce the size of this screen again so that I can go back to sharing my VirtualBox windows. So basically, let me go here, share this. So basically, I'm going to go here, and I can either choose the internal network or I can choose the host-only adapter. The big difference between the two of those, I'll show them to you again, is whether there is a virtual link, so that wire that I showed you in the whiteboard, whether that virtual link exists between the two VMs, or whether there's also a connection in that link to your host as well. For lack of a better explanation, if I just set it as internal network, only the virtual machines are plugged into the switch. If I set it to host-only adapter, then all the virtual machines can be plugged into the switch. And in addition to that, my laptop itself will have a virtual interface that's also connected to the switch. So for now, I'm just going to go with the internal network. And the way the internal network works is you can actually just give it some arbitrary name that, as long as you use the same name on all of your different virtual machines, then they will all be considered to be on the same internal network, or software-defined network, whatever you want to call it. So I'm going to save the settings. One of the complications that introduces then is that since I'm no longer using that NAT, right? Since I'm no longer using NAT, I'm no longer simulating that whole enterprise network, the router piece, which means that in my internal network, there are no other nodes on there other than the VMs that I've created, which means that there isn't another network device that's simulated in there that's going to be able to automatically give me an IP address or anything like that, which means that I have to manually do it. I'm going to go through this really quickly. It's basically the inverse of the operation that I did earlier. And so you can see that I still have the IP address that virtual device on the NAT network gave me. I actually need to disable that and go back to manual mode and then do this. And I'm going to just do just give it an internal address of some sort. I'm not going to give it a gateway, which is I don't need this thing right now at this moment to be able to communicate out to the internet. So I'm not going to try and implement that in here. And then I'm just going to apply those settings. So then again, just like before, I probably have to disconnect and then reconnect the network cable. So there we go. The network connection icon disappeared from up here. There's always good practice. It's sometimes the network settings will automatically detect it, or will just automatically change. Sometimes they won't. So we do it that way, and then you can see that it's not working. So actually, I'm not going to shut that down. So I'm going to leave it up. So the next thing that I'll do is I have done the same thing here. So for the Windows VMs, so as you can see, I use the same network name here. It's malware7038 for those of you who aren't able to read this. I will try and increase the size here. There. So for the folks on who are working off the projector here. So basically, both of them have the same internal network settings. They basically are on the same network. Again, this is only the virtual interface, so it's the software implementation of the hardware. I also needed to go into Windows here, which on Windows 7 is this little icon here. And then I go and I make sure that I change the adapter settings, which is over here on the left-hand side. So I can double-click on this thing, and then properties. So this one's a little bit more convoluted. It's not as obvious, but you want to set here. You want to change the settings here in protocol version 4. So not 6, but 4. And then, as you can see, I've already set them here. So I'll say that as soon as I set up my Windows virtual machine, I immediately, before I ran it, I actually changed the network settings to not be connecting via NAT and only be host only. And the reason for that was that I didn't want Windows Update to go out there and try and automatically start pulling down updates for Internet Explorer and for Windows and for whatever else that I may have on that system. So, because again, I'm going to be trying to use malware that was possibly, that was effective on an older version of Windows, basically. So, put it on the same network subnet, and then I can test for connectivity between the two of them. So then, now I can ping the other one. So I'm basically pinging this one. So that said, now we may want to be able to, say, test that we can capture traffic, see what's going on. So you'll use tools like TCP dump or something. So definitely helpful to read up on this tool. I will have more content about this tool and use it later on. But for now, what I can do is basically it sits there monitoring network adapter. In this case, Ethernet adapter 0 in Linux, which is the one that's set up as a default interface here. And it just tries to look for any traffic going to it. So if I start pinging this, what you can see is that all of my traffic is actually being kind of captured back and forth here. So it was actually able to see this one here is my Kali VM. So that's the VM that you're looking at right now. And then likewise, this one right here is the Windows host. So it might be worthwhile for me to also try and just see if I can ping both ways, right? Oh, just type. So there we go. So interesting thing you'll notice is that I actually can't ping the Windows machine directly from here, mainly because if I remember correctly, Microsoft's Windows by default disables receiving those unless it itself has sent out a ping, which is basically a security feature. So you can actually go into the Windows Personal Firewall. That might actually be useful. Probably. here we go, this thing. So remember correct, then it's because I've got this set up as a public network, or unidentified network. So I should be able to, if I go to this, again, I'm messing with the security settings inside of my virtual machine. You know, you probably don't want to do this to your laptop, but it's very helpful on the virtual machine to remove a lot of these mitigations so that you can maximize the likelihood of success of the attack that you're trying to analyze. So you don't want your security features to get in the way unless you're specifically testing those features. So we'll get, you know, this out the way, and then, and as you can see, it's now seems to have opened up a large amount of floodgates. And now that I've turned off the Windows firewall, you can see that I can actually get the ping responses. So I'll just kind of Control-C this. I'll let the pings go in the background. But basically what you're seeing here, this is how ping works. And this is actually how a lot of network traffic works in general. So ICMP, that protocol displays it very well, but in reality, all of the network traffic that you're going to be analyzing works like this, where you send a little bit of data to one machine and then it sends back data in response. Most of the time when you're visiting a website or something like that, the way the traffic pattern works is you send a request to the website and then it sends back a really large packet to you, or it may send back a series of really large packets to you. And then you'll respond periodically by sending back a really small packet back every time you've received a chunk that basically acknowledges it. So you're still having the back and forth traffic pattern occur. You just, you know, it's basically different for each one of the protocols. So that said, I'll go back up here and show you, this is what it was looking like before. So when it was failing, when ping was not displaying any results to me, what was happening was my Kali VM would try and send the packet to the Windows VM, and then it would wait for a little bit, and then it would basically try and send the packet again, and again, and again, and again, and again. So if you're seeing behavior like that, there's a very strong likelihood that some sort of firewall in the lab machine, like this, was interfering. So again, the way I got to that was I right-clicked on this little networking icon. I opened the Network and Sharing Center, and then over here under the C also on the left-hand side, there was Windows Firewall. And that allows me to basically turn it on or off right here. Also, there's a whole bunch of advanced settings that you can do if you want to. Yes, there is. Yeah, so the question was, isn't there a way to just allow ping without opening everything up? Yes, you could do that if you want. From the point of view of trying to analyze the malware and trying to allow it to succeed in any of its connection attempts, you probably just want your lab machines to be set up with completely what they call permissive firewall options, which is basically to turn that feature off. However, what I'm showing you now is that if I wanted to, and there's a whole bunch in here, great, so I'm not going to go through all these, but if I wanted to, I could add new rules in here. So let's see. So network discovery. Let's see if ICMP is even in here. I can't remember if I can search even. No, I can't. I can also add new rules. So again, this is just kind of running through the demonstration for the question of the class is using the advanced settings in the firewall. If I wanted to, I could go and create new rules using this new rule feature that's over here. and then it allows you to actually have control over network traffic when it pertains to a particular program or a particular port. So for TCP or UDP protocols, you have, in addition to the address, you also have port numbers that you're working off of. There's also some other kind of predefined rules. So Microsoft Windows itself has a lot of really common use cases that know it's used for, and so those profiles are put in here. So a great example is a lot of people use Windows systems for streaming media, right? So they have a video camera or something like that, a production studio or something, and they're just trying to show whatever their cameras are producing. They might actually have a sharing service or something, so it's got kind of a profile built for that. Likewise, it's got a profile built for iSCSI storage server. And then you can also do a custom rule, which allows you to edit. But all these basically allow you to, you know, I can pick a program path by looking for one on my C drive or D drive or whatever. Or I can say this applies to all programs. I can go and choose the protocol and port, the scope. So I can limit it. These firewall policies are very similar to what you'll see in a Linux firewall or something, which is you can limit, say, access to that service to be only machines. If I wanted to, for instance, harden my lab a little bit more, I might force all the firewalls to make sure that only machines using the IP addresses that I'm using in my virtual labs are there. So, but anyway, the key thing here is just can't interact with your Windows machine for some reason. Ping's a great test. So like, and that's kind of why I ran it through here. One of the more simple tools, but it's a great test to make sure that you get your lab set up. Because once you're working on setting that up, I should say once you get through the initial hurdle of setting all that stuff up, then they kind of, you know, that's basically where you want to get in order to move forward on analysis and everything, is you need a stable lab. So, yeah. So, once you have that working, then you might want to try doing something a little bit more complex, like actually being able to demonstrate sending data back and forth. One thing that I might end up doing is I might try and listen for incoming TCP connections on a particular port. What I'm going to do is I'm going to limit my traffic. One of the nice things about TCP dump, and Wireshark is just like this too. I just happen to be using TCP dump because you get that interactive component, and it's a relatively simple interface. Let me do something else really quick. Sorry, I'm just going to try and do this because it's very difficult to see here. That's more readable. It's very difficult to see on the projector in white on black. The white gets washed out. So I'll have it listening. There is a tool that's called Neckhead, and I'll show you the commands right here. I'm actually going to minimize this. So I'll show you basically it's simple utility that reads and writes data across network connections. Very simple description. This is a tool that allows me to connect to some service if I want to, like a web page, website, something like that, and interact with it, send it commands. So I can pretend to be a web browser with this if I know a whole bunch of the underlying protocol that a web browser would typically use. The other thing it allows me to do, it allows me to impersonate a service, or just impersonate a generic, kind of the generic concept of a service. The way you toggle between these two features is with the L flag, which basically means listen. So you can think of L as listen. Normal network speak when you are waiting, when you're a server waiting for connections to come in, you're typically called listening. And then when you are trying to reach out to a server, you're typically called a client, or you're maybe a connector or something like that. So what I might end up doing is I might run, I might decide that I want to run this on a port number. And a port number is just kind of a service identifier. So there's some common ones that many of you are familiar with. Most websites that are unsecure, so the non-SSL ones, usually listening on port 80. That usually means World Wide Web or HTTP. When you try and connect via HTTPS to any site, that is by default defined as being 443. So there's all these numbers from 0 to basically this, 0 to 65535, and you're allowed to pick any number within that range for listening, basically to run your services on your server. So it's kind of up to you to decide whether, or I should say it's up to a server operator to decide whether they care about following what the standard convention is or not. So today we're not really going to follow a standard convention, and what I'm going to do is I'm actually just going to have this listen for incoming connections, and I'll give it the port of 10,000. So one with 4 zeros following it. And then what I will do is go and bring this one back up as well. And you'll see that I'm listening, I'm waiting for stuff to come in, but just doing that does not actually put anything out of the network. There's no such thing as a service announcement or anything like that with your standard raw TCP/IP. So then what I'm going to do is I'm going to try and use, I like to use Telnet on Windows machines, mainly because it gives me a nice, and I'll show it to you in a second, it gives me a nice message that tells me whether the connection succeeded or not. And also it does kind of interactivity pretty decently. So 1 to 10,000, right? So, oh, Telnet's, oh, maybe Telnet's not installed on here. Oh, okay. Well, give me a second. I will get Netcat for Windows then. So this is a good example. I'm glad I kind of ran into it. So here, while we were working through this thing. So let me just see what I have. Yeah. So I installed the guest editions on here on the Windows system, and that gives me two things. That gives me the ability to basically resize my desktop, and it automatically adjusts, which is handy, but not necessarily a critical feature. The thing that is a critical feature, however, is it gives me the ability to do this. So basically take a folder I have on my machine. So apologies for kind of the detour, as we were just doing the I want to go and have the two machines talk to each other demo. But I'm actually lacking a program on my Windows machine that would allow me to have the two things talk to each other. So I need to get that into my Windows machine. But I don't want my Windows machine to connect to the internet to do it. So I want to get it on the Windows machine using a different channel. So what I'm going to do is I'm actually going to get a random folder that's on my host, that's on my laptop. So that's out here. And it's actually this folder, right? I'll bring up. So it's actually my downloads folder. So somewhere in here, I'm going to download this. Here we go. I'm going to download this tool, which is basically not in that. I'm going to download net. Here we go, NCAT, right? So did I pass it up? Probably did. I'm just going to go back out here and I'll get this one. Okay, here we go. So Neckhead for Win32. So I'm going to download it, and it'll automatically go to my download files, download folder, or whatever. So as you recall, that's the one that I've shared in here. So I told VirtualBox that I wanted to use this shared folders feature, which isn't a real hardware feature. This is where you kind of get into that para-virtualization thing that I was telling you all about last week, is that in addition to simulating hardware, VirtualBox also has this facility that allows it to kind of provide software interfaces for different concepts as well. And in this case, what they decided to do was create a fake, let's see, I don't think it's in here. Can I do this? No, I can't. It's this one. Oops, I clicked on the wrong one. This one. So it allows me to actually create a network, or I should say a network system that pretends to be another computer that has a shared drive. So this VBox server right here, this actually isn't a computer with an IP address or anything like that. This is just a make-believe that's created by the VirtualBox guest editions within VirtualBox that allows me to have a very familiar interface. So they chose to do it this way because most Windows users are at least familiar with sharing network drives and then using network mapped drives and network mapped shared folders to drag and drop files back and forth. So what I can do, so I can go and grab this thing. I'm just going to extract it in place. And then here is the Neckhead application. So, oops, I'm going to rename it. I'm going to copy it. And I'm just going to save a copy of it inside my, we'll say, IE user is the default user that's put in here. So we'll paste it right here, right? And then that means that it's right here. So you can see that now that file that I got in is right here. And then if I want to, I can then remove the shared folder if I want to. One good reason for doing that is, for instance, if you happen to be playing with ransomware, like I talked about earlier, use ransomware as an example, which a lot of people are more familiar with today than they were about a year ago. I do not want ransomware to discover that VBox server, that was there. Whoops, there we go. I don't want, so you can see I'm looking at the VBox server now. It's still there, but it doesn't have any drives connected to it anymore because I just removed that shared folder. I don't want someone to go and explore that kind of fake network and then destroy everything that's in my downloaded folders. So I get into a habit of basically sharing the folder opportunistically when I need it, and then taking it away when I don't. That said, I still have Neckhead in here, so that Neckhead exe was physically copied from one place to the next, and now I can basically do this. So let me see if it, so it'll show me the help for it and everything like that. So I'll do this again so you all can see it. But basically, let me move this hand out of the way. So basically, it has the same options as the other one. So I can connect to and then what you can see is that my thing right here says that the Windows machine used, so the Windows machine initiated a connection to the Kali machine. So I'll show you the IP address here of the Windows machine. And then Kali machine just shows up as Kali because that's the host name. and Linux likes to auto-resolve those things. That's a feature that you can, in the options, there's a way to turn it off for TCP dump. But, you know, for lack of a better term, this Kali that I've got selected here is just interchangeable with 192.168.2.2. And then it says webmin, which webmin is the name of port 10,000. Because people who use the webmin web-based system administration tool, by default, I guess, it likes to use that port. So what it did is it initiated a connection, and then my Kali Linux system responded back with another packet acknowledging that, and then the Windows computer responded back to that. So we got three different, basically back and forth, or what's known as the three-way handshake, sent that final message back to the Kali system, so back to what I'm looking at now, confirming that it got the acknowledgement. So basically what happens is, I ask you if you want to connect, you say, okay, you can connect. I say, okay, I will connect then. So basically it goes, you know, there's a bounce, three-way bounce or three-way handshake. So now, if I want to, I can send messages, right? And you can see them pop up over here. And then you can see the packet metadata. So the other thing is that by default, Kali doesn't send all the contents. I mean, TCP dump doesn't display to you all the contents. So what I'll do is I'll do this -x, which if I remember correctly actually is what you use to actually dump the content of the packet in hexadecimal format. And so it uses X as kind of a you know, shorthand for hex or hexadecimal. So then you can see test went through, and then you can see that the packet, this is test right here. So test was definitely in the message. There's also a whole bunch of other stuff that's in here too. So I'm not going to jump into all of it, but suffice to say that I believe that, if I remember correctly, these ones right here is the IP address, and that would be the IP address of the recipient. And then this right here is the IP address of the sender. And then there's a whole bunch of other data in there that, for instance, that port that was 10,000, that needs to be encoded. The other port, the fact that this one's 49176, or any other port that it would be, because that one's actually randomly chosen. So that's another thing too, is that whenever you are connecting, port is randomly chosen on the initiator side to basically be the destination port for any for any responses. So that's also somewhere in there. And then there's a whole bunch of other data that's included in there as well, such as this is encoded in there somewhere. This is encoded in there somewhere. You know, all these, you know, all this data is actually encoded in there somewhere. And I'm not going to dive into all of that because most of that is there's like a networking class that I believe undergrad and graduate level networking classes that'll touch on what a lot of those fields are. But you should have access to, or you will receive access to some of that information during this class, just like you probably did or will have with vulnerability assessment or cyber defense overview. So, but anyway, the basic reason I kind of put together this example was we got to cover the shared folder system, so how to set up the shared folders that allow you to marshal stuff into and out of your virtual machine. So for instance, if I didn't deal with any malware today. Had I dealt with malware, I may have been dumping stuff onto, onto the virtual machine here. Of course, I wasn't doing that. Or I might have been dumping other files onto the virtual machine here. I wasn't doing that this time, but had I been, and we'll kind of showcase that, I guess, Thursday, is that I would actually want to collect those artifacts up. I'd want to collect them up, and then I'd want to either save them to my laptop using the shared folders, or even save them out to the Kali system using something else. So, like, I think this still works. So, we can try this, right? So one thing that's nice about Kali, or about Neckhead, is that I've used it before like this. I'll try and use it again like this and see what happens. Is so then I can't remember if it works that way or not, but basically exe, so you can see that I basically just do Notepad. Oops. I always forget how the tab completion works on Windows. So you can see that basically here's that MZ, and then this program, something or other, cannot be run in DOS mode. So it's basically just like this program. So basically, I was able to so basically I was able to copy this file over using Neckhead. So I was able to shuttle it over to my Kali box using Neckhead. The nice benefit to what I did there, so you can see what I did was I basically ran this, and then from here I basically just used the redirection to pipe it into Neckhead. So the nice benefit to this, when I use this type of technique a lot for getting stuff from one VM to another, it's easy because I don't have to try and figure out how to set up an FTP server on one of them. And it allows me to transfer the data from one to the other without having to use my host machine as an intermediary. So for instance, I avoid the kind of messy, complicated problem of trying to disable antivirus on my laptop. Like, while I'm doing all this and I'm trying to mess around with malware, I still want my laptop, the one I do all my schoolwork and all that stuff on, or I don't want to, like, lose my dissertation research and stuff like that. I want that system to still be protected. So using kind of a mechanism like this, and I'll make sure that this stuff makes it up into a kind of entry on the website, similar to some of the last, the last year's lectures went. But I use a mechanism like this to basically very easily shorthand transfer data back and forth. The other thing that's useful for this is from the attacker perspective, is that if I want to get another backdoor, so if I've broken into a system with a really simple exploit against maybe one of their applications like Flash or something, I may be very limited in the tools I have available. If I want to get more complicated tools or get more files on there, or if I want to steal files off of there, I might use this mechanism for that. And so that would be an example of the type of actions that you might find yourself having to do when you're trying to kind of demonstrate an attack that then you're going to, say, unwind. Because I will say, and I believe I talked about it in the first lecture slides, malware is not just a tool. So malware doesn't typically end up being the thing that does all the bad actions, right? It's usually a person who's executing and controlling malware to go and get the effect that they want against your system. And that is very often what you're trying to analyze, is not just what the tool is for or is made of or looks like, but also how the tool was used to achieve its desired purpose. Because, for instance, I just gave you an example of how I could possibly employ Neckhead, which is a totally legitimate tool. It's not malware, but I could use it for malicious purposes, thus making my use of it malware. So, all right. That's all I have for today. It looks like the recording worked, so this lecture will go up. I don't believe it happens immediately. I believe it takes a little while for them to get that onto the, or at least it took a little while for them to get the last lecture up. So as soon as I see that, I'll try and get it up, and then I will also create a new entry that has some notes from some of the different pieces that we touched on today. And then we will run through a actual attack using, or basically an attack where I deliver malware on the system, and then I try and basically use a lot of the tools that I showed you today in order to basically pull files off, stuff like that. So anyway, have a good one, everyone, and I'll see you on Thursday.